Game theory as we know it today came about in part because of one man interest in poker. This man was not just your average man on the street. He was mathematician, physics, and computer scientist named John von Neumann. His goal was loftier than becoming a better poker player. According to Forbes' article, he was only interested in poker because he saw it as a path toward developing a mathematics of life itself. He wanted general theory, he called it game theory, that could be applied to the diplomacy, love, war, evolution, and all business strategy. He moved closer towards the goal when he collaborated with economist Oscar Morgenstern on a book, The Theory of Game in Economic Behavior in 1944, in which Morgenstern asserted that any economic situation could be defined as an outcome of game between two or more players. What is a game according to the game theory? Yale economist Professor Ben Fowler notes a game has three basic components: players, strategies, and payoff. As we just mentioned, game theory applies to the game involving two or more players. In the game, player shares common knowledge after rules, available strategies, and possible. However, it is not always the case that players have perfect knowledge of these elements of the game. Strategies are the actions that players take in a game. Strategies is at the heart of the game theory. Fromm described the theory presented in the theory of game of economic behavior as mathematical modeling of the strategic interaction between rational adversaries where each side action would depend on what the other side would do. The concept was strategic interdependence. The action of one player influencing the action of other player is one important aspect of Newman version of game theory that's still relevant today. And then there are payoffs, which one should describe as the outcome of the strategy applied by the players. It could be a wide range of things depending on the game. It could be profit, peace treaty, or getting a great deal on a car. One limitation of the Newman's version of the game theory is that it is focused on finding optimal strategies of one type of game called zero-sum games. In a zero-sum game, one player loss is the other player's gain, according to Forbes. The source notes that players can neither increase nor decrease the available resources in zero-sum game. Critics have noted that life is often not a simple zero-sum game. More complicated scenarios are possible in the real world. For example, players can do like find more resources or form coalition that increase the gain on several players. Game theory has evolved to analyze wider range of games such as combinatorial games and differential games, but we have time to look at only one. The classic example of games often studied in the game theory is called the prisoner's dilemma. This version is from the Fundamental Finance website. There are two prisoners, Jack and Tom, who have just been captured for robbing a bank. The police don't know and have enough evidence to convict them, but know that they committed a crime. They put both in interrogation room and lay out the consequences. First, if Jack and Tom in separate if both Jack and Tom confess, they will each get 10 years in imprisonment. If one confesses and another doesn't, the one who confesses will go free and other will spend 20 years in prison. If neither person confesses, they will both give 5 years of different crimes and they were committed so far. If Prisoner's Dilemma has basic ingredients of game, the two players are Jack and Tom. There are two strategies available to them: confess or do not confess. The pay of the game range from going free to serving 5, 10, or 20 years in prison. As Fundamental Finance explained, it is easier to see and compare these outcomes payoff if they are put into a matrix. Since Tom strategies are listed in rows and x-axis, this payoff are listed first. Jack payoff are listed second because his strategies are in column or in Y. C means confess and C means not confess. This matrix is called normal form in game theory. Moves are simultaneous, which means that neither player knows the other decision and decisions are made at the same time. In the example, both businesses are in separate rooms and won't be let out until they have made their decisions. Solution of this game is that both will confess and go to imprison for 10 years. To find the solution of this game, how we reach it, join game theory class please. Nash equilibrium can be used to describe many social problems and answer to the question that's why the decision made by rational players or are not conceived in real life. You will see that in the class that the rational solution of the game could have been 2 years of imprisonment, but prisoner's dilemma doesn't reach to that solution. Similarly, real life is full of such social situations where solutions are clearer reflection of prisoner's dilemma. Why is rationality not always guiding principles? To model these situations, to explore the reason, and to get the answer. Join the class of game theory, Econ 406. Hi everyone, I am Azma, instructor of Econ 406. After the brief introduction of this trailer, I will provide a brief overview of the course. This course is designed to cover the following aspects. So game theory is divided into two types of games. Normal form games, extensive form games. If we talk about the normal form games, that can be in 2 players to n players game, can be from discrete actions to continuous action game. When we talk about the methods, there are 4 types of methods which will be covered under game theory course. Those methods include Nash equilibrium, dominant strategy equilibrium, iterated dominant strategy equilibrium, and the last one is best response. And after doing all these methods, we will move on to the application of these methods to economic situations. The most importantly, we will apply these methods on oligopoly games, and oligopoly games are covered under 4 types of models: Uno model, Stackelberg model, Bertrand model, and Monopoly. And then we will start the second session of this course. Will start with extensive form games. The extensive form games is categorized into 2 further details: with complete information and games with incomplete information. In order to go with the complete information game, there are 2 methods which are adopted. One is backward induction and second is sub-game perfect Nash equilibrium. When we talk about the games with incomplete information, the one method which is available to solve such games is called Bayesian method. So guys, welcome to the game theory class, and I hope that with this trailer you have some better idea that how the course will go on and how it can contribute into your life. So what you are waiting for, join me class of Econ 406 Introduction to Game Theory. See you in the class. Thank you.